Okay, welcome back everybody. This is the second part of Chapter 11, which I am treating as Unit 1 for IB Chemistry here at North Shore High School. So what I wanted to talk to you today about were significant figures. Significant figures, they sort of give people a hard time. And I think that comes from the fact that people don't really understand where significant figures originate from. And I'm hoping that after you listen to me here and practice some problems, you'll see why we use them. Now, when you are using a piece of equipment in the lab, it's pretty obvious what you should write down as a number to some degree. So, for example, if I were to give you a scale, and I were to say, well, here's my scale, and on my digital scale, I have a sample of copper, and it weighs 45.32 grams. Our scales go to the hundredths place. Well, this is what I wrote down because the scale said that. And so now if I were to try and go ahead and, write this down and I were to report it as 45.32658143, your lab partner and me and everybody else would say, where did you come up with all of these numbers? Because those aren't on the scale. And so basically you took the liberty of inventing a total of 6 insignificant values. We want to keep the numbers that we use significant. If we start adding numbers that don't matter, then we are not doing ourselves any favors and we're making stuff up. But this seems logical, right? But let's say that, in the laboratory you were measuring density. Density is mass over volume. And our mass, let's say, is 15.3 grams. And our volume is, let's say, 2.5 centimeters cubed. And so I put these in to my calculator, 15.3 divided by 2.5. And when I do that, I get 6.12. So this is my number on my calculator, and I have 6.12. Well, it turns out that that number isn't really correct. Number should be rounded, because the measurements that I took, they don't convey that level of accuracy. And that's because this number down here has 2, and this one has 3 significant figures. So I need to round this. I need to round this to 6.1 grams per centimeter cubed. And doing that will allow me to round it correctly based on the measurements that I took. And we can see that here. We're just looking at a simple number. Right here, I go from 0 to 6 point something. So now, student A, well, they know when I read an analog scale, I guess at the last place. The smallest increment here is 1. So I'm going to round this to 6.5. I'm going to go to the tenths place. Well, in this case, I made up this number. This was a guess. But using analog equipment, that allows me to do that. Over here, these, let's say, is a graduated cylinder, and a student records this, they know it's 1.5 or 1.6, so they record it as 1.54. Well, they recorded this value here, this was guessed. And so they have a name for this. They call this one uncertain. Well, it's uncertain, and so is this. This is also uncertain, but it's still considered significant. So uncertain but significant. And when we define significant figures, those are the numbers that we're measuring, plus we have one more number that's estimated. That is our uncertain number. Now, you've learned about significant figures. Should be kind of review for you, whether you took chemistry last year or physics. So any number that isn't a 0, it's going to be significant. Those are in green. But zeros can be significant. They can be significant when they're between two non-zero numbers. So these zeros here are significant. This 0 is between two non-zero numbers, so it is also significant. Same thing with this 0 here. It's between a 5 and a 3, two non-zero digits. It is considered significant. Now, if you have zeros at the end of a number, well, those will be significant if there's a decimal place present. So if there's a decimal present, the zeros at the right end of the number are significant. Non-significant numbers, those are where you have the leftmost zeros. Especially when there's a decimal present. If you see there's a decimal present here, these leftmost zeros are acting as placeholders. So you have a value here. This 7 is in the thousandths place. The zeros in the tenths and the ones place, the tenths and the hundredths place, excuse me, and the ones place, those are holding the place for that thousandths place number. If you don't have a decimal present, then those rightmost zeros are placeholders. They're holding the place for this 7. Now, how can you go about this and say, I don't want to include these zeros, they're confusing for me? Well, you can use scientific notation. Using scientific notation is helpful because if I want to express this 300 here, well, I just write 3 times 10 to the second. This number here is telling me how many significant figures I have. I have 1 significant figure. Now, you might have learned this shortcut. It's called the Atlantic-Pacific rule, and basically what you do is you draw United States. And, here is my Pacific Ocean. And here is my Atlantic Ocean. And the rule is kind of fun. If I have on the left here, P, Pacific, stands for a decimal that is present. So if there is a decimal present in the number, I count from the left. And I skip all the leftmost zeros. If I am at the Atlantic Ocean, there's a decimal that is absent, so there's no decimal. And so I skip the rightmost zeros. Rightmost zeros. I think it's Zeroes. I don't know. So let's do an example here. If I were to actually look at this and say, okay, well, I have a number where there's a decimal present, so I have 0.03601. Well, there's a decimal present right here. I count from the left. I skip the leftmost zeros. These are placeholders. I start counting 1, 2, 3, 4. This has 4 significant figures. Notice the 0 between the 6 and the 1 is significant. If I had a number with a decimal absent, I'd have like 5,010. So if I start counting from the right now, I skip the rightmost zero. That's a placeholder. 1, 2, 3. This would have 3 significant figures. Now things get a little bit complicated because here I want to show the number 7,000. I want to show it with 2 significant figures. It's impossible to do here because here it has 1, no decimal, I count from the right. If I do this, it's going to have 4 because now I'm going to count from the left. I can't do it either way, so I need to put it into scientific notation. Scientific notation, it gets rid of the ambiguity. You want to get rid of ambiguity, use scientific notation. So how does this apply to measurements here? So, I look at this and I have 2.5, 2.6, 2.7. So my arrow here is pointing between 2.6 and 2.7. So I'm above 2.6, I'm below 2.7. remember I can estimate that last digit here. So I know it's less than 2.7. I know it's greater than 2.6. On the slide here I tell you that it's 2.63. So this is going to be my number. This last 3 is uncertain. Okay, so I picked a 3 there, it's uncertain. Again, my lab partner could be, no way, 2.62. We're both right. They're both significant. This means that this number here is going to have 3 significant figures. When I do a calculation with this, we need to take that into account. So go ahead, pause the video, try this out, tell me how many significant figures there are. You know, I'll do one with you. I'll pick like this one here. I look at this one, there's a decimal present. So I count from the left side of the number. The first number is not 0. I count 1, 2, 3. This should have 3 significant figures. Now, after you've done that, hopefully you've gone through and you did those. Let's look at, what you do when you calculate something. Addition and subtraction. When you add or subtract numbers, you round to the same number of decimal places as the measurement with the least number of decimal places. Well, let's look at this one here. This example, I have 2 decimal places. And this one here, I have 3 decimal places. And this one here, I have 1 decimal place. When I put this into my calculator, I get 3 decimal places. But I need to round. I need to round to 1 decimal place. 1 decimal place would be, in this case, it would be the 3. So that's 1 decimal place. I round to 131.3. Take a second and digest this a little bit. Try another problem. Here's one for you to do. Let's say I have, 52.63 minus 8.251. So subtract these two. Tell me what you get in your calculator, and tell me what you get when you round properly with sig figs. I want to know. We'll talk about it tomorrow. We'll see what you get. Multiplication, division, these seem, more straightforward. You're going to round to the least number of significant figures. So I have these two numbers, the 0.7 and the 98.457. This has 1 sig fig. I have to round my answer to 1 sig fig. Look at what I got in my calculator here. I got something with 6 significant figures. So now I need to round this to 1 sig fig. So if I round this, I would say, okay, well, 68. Or actually, 69. Well, that's 2 sig figs. So I need to round it to 1 sig fig. So I try 70. That works. But if I was unsure at this point here, I could say, well, 6.9 times 10 to the first. Well, I could round this to 7 times 10 to the first. And that would be in scientific notation. So this is our, spiel on significant figures. I'm going to stop here for now. This is longer than I thought it would take to make this video. But hopefully, practice some of these. I'll give you one more just for fun. Let's say I wanted you to multiply 0.6342 times, or we could divide. Let's divide. I'm going to move to divide. So we're going to divide by 5.1. So divide these out. Try it out. Tell me what you get. All right. See you tomorrow.